Welcome. I hope you're having a good week. This is a quick recording on our next gas law, which is called the combined gas law. So this chart here shows the three that we've done, the three basic gas laws. Now we're going to combine them into one, which is the combined gas law, and then we'll do the ideal gas law next week when I'm back. So the combined gas law is just that. We're combining the three basic gas laws into one. Nothing is being held constant. And what this does is describe a gas in an expandable container whose pressure and temperature changes. And so this, I believe, comes from your course. If you go through the combined gas law section, you should be able to play around with this if you choose. So we're just going to dive right in. It's basically the same thing. We're just plugging into this combined gas law equation now. And we need to pay particular attention to reading the problem and making sure we're choosing it. This one's unique in that there's 6 variables, so it has the most numbers, I guess, in the problem when we're reading it. There should be 2 of everything. So if initially I have a gas at a pressure of 12 atmospheres, a volume of 23 liters, and a temperature of 200 Kelvin, then I raise the pressure to 14 atmospheres, increase the temperature to 300 Kelvin. What's the new volume? And so again, we have 2 of everything. The steps are still the same. Let's list all of the variables. I know it's the combined gas law again because I have 2 of everything. Make sure all of the units match. So we have atmospheres, liters, and liters is what we're looking for. And our temperature is already in Kelvin, so we're good to go there. This one looks like it should be 300. Alrighty, and then you just write the equation, plug in, and solve. You could see it over there. And then I adjusted since there's only one significant digit in the temperature values. I'm going to go ahead and do one more example or share one more example with you. In this case, we're solving for volume. In this next one, we're solving for temperature. Nothing's really changed. It's just that now we're solving for a variable in the denominator of a fraction. So again, we're just being careful that the math is okay. For this one here, it says, if I have 2,900 milliliters of gas at a pressure of 5 atmospheres and a temperature at 50 degrees Celsius, what will be the temperature of a gas if I decrease the volume to 2.4 liters and decrease the pressure to 3 atmospheres? So again, as I read through, I see 2 of everything, so the combined gas law. I've listed out all of the variables. My units match, but this time I am given Celsius, so I have to change that over to Kelvin. And then plug in and solve. In this case, I left the answer in Kelvin, but since the initial temperature was given in Celsius, you may find some questions ask you for the final answer in Celsius as well. And if that's the case, you would just subtract out 273 to go back to Celsius. So the next few slides are just some examples. You could read through, pause the recording, and then go to the next slide to check your work. There are 4 of them. So here's the first one. You could pause the recording here and give it a try. Before I go ahead and move to the next problem, notice this one says, what was the original pressure? So you want to be careful. What makes this one unique is that they're asking for the initial pressure, and typically we solve for the final. So I'll pause here one more time if you need to go back and take a look. Great, here's the answer. And so again, you want to be careful. We're solving for that initial pressure this time. Everything else is listed. We have to change both temperatures to Kelvin. Liters match, and we're solving for atmospheres. I'm going to move to the next one. This one, I'll again pause the recording, give it a try, and then when you're ready, put the recording back on. I'll flip to the answer. Right, so what makes this one unique is that they're telling you you have initial conditions at STP, so you have to know what STP is. And then they're also saying we're reducing the pressure by half, so not actually telling you the number, expecting you to do that. So again, pause the recording here if you need to take another look. Right, so I'm going to go ahead and flip to the answer. Standard pressure is 1 atmosphere. Standard temperature is 273 Kelvin or 0 degrees Celsius. Our initial volume is 2 liters. We've reduced the pressure by half, so we make this 0.5 atmospheres, and we're given the last Kelvin value. We're solving for volume. Okay, 2 more. Here's the next one. I'll let you read through, and when you're ready, put the recording back on and check your work. Right, this one is a little bit unique again because it's asking how many liters did I start with. So again, we're solving for an initial value. So pause the recording again if you need to take another look. Here's the answer. Again, we're solving for initial volume. Atmospheres match, Kelvin matches, so we just have to plug in and solve. Last one. There you go. Pause the recording, give it a try. Right, this one's just straightforward, but solving for temperature, which is in the denominator again, so just some extra practice there. And there's the answer. And that is it. So I'll have this homework open up in the course. If you have any questions, please let me know.